Welcome to BKW Physics. I'm Mr. McConley, and we're going to just pick up where we left off yesterday. Yesterday we saw the motion of a little Jeep toy, a tow truck, which just was basically, you just rolled it and it rolled to a stop, and a pullback vehicle where you pulled it back and let it go, and it sped away. And we came up with some graphs, and for the Jeep, what did we say the distance time graph was? People in the crowd just yelled out. What did that look like?
A linear
line like that. What about its velocity?
Distance to a horizontal line.
It was a constant, so it was a horizontal flat. The tow truck now was different because the tow truck was slowing down. So we said this curved until it flatlined. And the velocity looked like, not straight down, but at a diagonal down, but a straight line, linear. And then the pullback,
exponential,
which we said was exaggerated because that thing wasn't speed up much, and the velocity therefore was. Okay, the other thing we said was if we took the slope of this, it gave us that, right? And we said it in more words, but that was the idea. And then we said if you took the slope of one of these, it would lead us to this new concept of acceleration, which we have to explore a lot more. But the one thing I wanted to add to this is another way to represent, besides graphs, besides words, another way to represent motion is by using dots. So think of it this way. If this Jeep had a trunk, and in the trunk of the Jeep there were like a bunch of M&Ms or something, and at a regular interval, an M&M were to drop out. 1, 2, 3, 4, 5. Just these M&Ms were dropping out. What would the pattern be with Jeep? How would the M&Ms be spaced? What would it look like? Equal space. So in a dots representation, I'll try to make these equally spaced. Of course, I'm just freehanding it, so it'll look like. In a dots representation, it would look like that. The dots would be evenly spaced. How did that compare to the tow truck, which was slowing down? If they started out like at a space like this, that space would shrink down until basically something like that. Then you're getting closer together, right? What would it look like for the pullback? It would start close because the pullback was basically hardly moving at first. And then they would start moving up. This is just one more way that you can represent motion, and it's another visualization that helps some people see what's going on. If you think of the dots, each dot represents a piece of time. So if each dot represents 1 second, you can see that, like for the tow truck, after a while, 1 second only represented a little bit of distance. But for the pullback, towards the end of the run, 1 second represented a lot more distance. We're actually going to do a lab to follow this up in lab class, where we use what's called a spark timer. So for today, short lesson, physics.